Let's go through LeetCode 529, Minesweeper. So this question gives us a board, which is a char, two-dimensional char array, and a click, which has the integer array, and it will represent the row and the number of clicks. And the question is ask us after this kind of click, and this click happens, we should follow this kind of 3 rules, trying to see what the board will look like after the click. So the question says that M represent an unrevealed mine, and E represent unrevealed empty square. B represents an revealed blank square that has no adjacent mines. That means, for example, let's look at this one, right? This one, this is an revealed block, and around the adjacent cell, it does not have any boom or mine, right? So also the digit 1 to 8 represent how many mines are adjacent to these revealed squares. For example, this is 1, right? So let's see, in its corner, there is 1 mine here, and X represent a revealed mine. So for this question, it has 3 rules. Return the board after revealing the positions according to the following rules. So let's look at the rule. If a mine M is revealed, then game is over. You should change it to X. For example, there is an unrevealed mine here. If the click is here, right, we just change this M to X, and then return the board. And the second rule is that if an empty E with no adjacent mines is revealed, then change it to revealed blank, right? So like, for example, this one, right? So we'll just change it to B. And all of its adjacent revealed square should be revealed recursively. That means after click this one, we know there is no mine around this cell. So for its neighbors, we should try to check, run those kind of rules again. 3, if an empty square E was with at least 1 adjacent mine is revealed, then change it to the digit 1 to 8, represent the number of adjacent mines. For example, if we click here, right, then we just change this one to B1, right? So this one, then it just finishes the next. We don't need to recursively to reveal the cells around it. Then return the board when no more square will be revealed. So for this question, it is actually simplified to the Minesweeper. We know for one Minesweeper, for example, if we have if we have an already revealed some of the cells around a boom, right? We should the game automatically change the M to X, right? So if a cell around it are all being revealed, it will change to X. But for this question, it does not have this kind of conditions. So X only means the game is over. So they simplified our question. We don't need to worry about when we do these questions. We have, no matter it is what kind of code we are writing, if we see that X means the game is over, we don't need to worry about there is a X, whether we need to count it, whether it is a boom or not, whether it is a mine or not. So for this question, we just, it's like a simulation. We just doing one click and follow these rules, trying to see what kind of board it returns. So let's write code. So we'll say at the beginning, we'll say the click can only be unrevealed squares, right? That is M or E, right? So let's get the click row. Of course, we can write the corner case, right? If it's for the row column that's not equal to E, or that's not and it doesn't equal to for the row column doesn't equal to M, right? That's still the unrevealed one, right? Then that means it is invalid click. It click unrevealed still. Then we just return board. Okay, so that we'll just follow these kind of rules. If M rule one, let's write rule one, right? Rule one. If M is revealed, then game is over, change it to X. If for row column equals to M for row column is to X, then return board. Then we just follow. Then if it's we click and cell which is not an unrevealed boom, then we just do DFS. Just intuitively, we can do DFS to, for example, we click here, right? We click a cell. Then we from its 8 directions, we try to DFS to see whether those kind of neighbors are also E or some kind of number. If it's number, the DFS stop. If it's E, it will continue iteration. So let's write a DFS function. DFS board row column return board. So private void DFS char board int row int column. For this row and column, first we need to count around it how many boom or how many mine it is, right? So we have a count here. Then we need to see its neighbors. Let's write this. let's say for it's 8 directions. Mm, so let's first say if it's not inbound. Continue. Also, we need to write a help function. Mm, this is inbound. If it's not inbound, just continue. We are trying to see if for new row, new column equals B, right? This revealed, sorry, this should be M unrevealed. Um, man, B is blank, sorry. If it is man, right? So here we know it will not be X. If the X happens, that means the game is over. But we can have some kind of follow up. So if boom, all of its neighbors are revealed, possibly we can change IM to X. In that case, we go to every time we go to M, possibly we just do a check its neighbors, but it's not does not add too much complications for these questions. So if this one equals M, then we count how many mines are on it. So we are going to see the next. The next is that we have some rules. Let's say the rule 3 is that rule 2 is that no the empty square, right? If rule 2 is that if count equals 0, we need to recursively to do the cells around it. So we'll say it's this one. We need to by the rule, we need to change this row column to B, right? That is revealed boom. also we need to go and let's write else board row column equals char plus count. And for all of its neighbors, for equals there, smaller than 8, right, plus int new row is row plus 0 I int new column plus t column I. If board isn't inbound, right? Board new row new column. Just continue. Also, say that if an empty square, if the E has no adjacent mines revealed, then change it to a revealed B. And all of its adjacent square should be revealed recursively. Then we just write yes, board new row new column, right? Here, that is the new row, new column. It may be some of the cells we already revealed. For example, it's already been some kind of numbers. That means it's already visited, right? Or it can be some kind of B, right? We already revealed before. So that means we already visited that cell. So we can have some kind of prompt here if board new row new column current equal to E. We also continue. We just DFS for the new row new column which equals E. That is unrevealed empty square. So this is a DFS solution. DFS solution, say we iterate. We're going to uh, iterate the whole board for every cells. So the time complexity will be O M multiplied by N. Space complexity will also be we have, for example, O M multiplied by N. Here the thing is that we say that the M and N smaller equal to 50. So we know this kind of DFS iteration should be less than DFS iteration times should be less than 2050. So use DFS should be fine. There shouldn't have no issues which will be Stack Overflow. We know if this one M and N will be a large number, for example, M and M greater equal to 10,000. Use DFS may have some risk to have a Stack Overflow. So if we should think about in that case, if this number is a bit big, we can change this one to, let's write this is comment rule 2, right? This is rule 3. Rule 3. We can change this kind of scenario to something like a BFS. Because BFS is using a stack, not so it will not have those kind of risk to be Stack Overflow. So let's write the BFS solution as well. So we know for BFS, we need to have an queue, right? We need to have a visited, so we can have an Boolean. So we need to change the logic here a little bit. So also we need to have the related row one equal to true. And we'll say why Q is not anything. It current is Q for it we already have a row, so we use R. For this one, we also need to count this logic, right? So we also need this logic to count how many months around it. This will be R. This will be C. Okay. Yeah. So here we put this one inside. This root that if I run it, there's no count to change it to 0. New row equals row column. And we'll add if visited new column. We just continue. Then we BFS and visited new row, new column equals true. So this will be the BFS. Now the 36. Okay. Yeah, so this is a BFS solution. So the time complexity, space complexity will be the same, but because we use a weighted array, so space complexity also and multiply n. But the thing is that if this the data give us a range that is smaller or equal to 50, so DFS is fine. But if, for example, we have m greater than 100 and n greater 100, and the iterations use DFS will be greater than 10,000. The DFS may have the stack overflow issues, so we just need to be careful about that. Of course, intuitively use the DFS more straightforward for this question. Okay.